Hello. In this video, we're going to go over our second unit, which starts with chapter 2 in your textbook. We're going to go over something you are familiar with in your statistical classes. However, the purpose of this unit is to show you how the descriptive analytics started to appear and how it is linked to your previous knowledge in descriptive statistics. So consider this chapter as a review to your past knowledge of statistics, and top of it the latest graphical charts and more analytical concepts involved with statistics. First of all, let us start with this very simple table, which consists of pizza preferences collected from 50 college students. So they asked the students which pizza they prefer the most, and accordingly they wrote down the names of those pizzas. As you can see, this information doesn't reveal any useful information for us, and we should think about something, make it more easier to comprehend and to analyze. So the idea is that we have, first of all, qualitative data. This is not numbers, this is a qualitative classification. We have some type of names that identify each item in this table. So we're going to summarize this data using something you are familiar with, which is called frequency distribution. Frequency distribution is really easy. You create a table in which you summarize a number of items in each of several non-overlapping classes. So let us go back to our table. So this is our table, and now we're going to present this table as a frequency distribution. So how many times the Bruno's pizza was mentioned, you count them, you add the frequency of it, and you sum them up, should come up with the total number of those represented in the table. Now, there is another concept, not only frequency distribution, something called relative frequency, which is provide you with some idea on how representative, for example, the Papa John's with 19 times preferences from those students over all the data, which is 50. So how much 19 relatively represent over the total number of pizza preferences? So to do that, you just divide the number of items over the total. So for each one of these, we come up with these numbers. And also we can represent them as a percent frequency. We just need to multiply it by 100 and add the percent. So this is some of the ways you can represent qualitative data during the semester. Now, we don't only present the data as tables, we also can chart them. And some of those charts, since we have percentages here, and 100% can be represented as a pie chart as well. So you can see most of the analytical books consider using either the bar chart or the pie chart. So this is the same data. I put it in the way you saw in Excel, and if you just pick the bar chart in Excel, you should be able to see something similar to this chart. And also, if you want the pie chart, you should be able to come up with something similar to that. Also, there are supplement videos that show you in steps how you can do those, so please refer to those as well in Blackboard. Now, another concept which is maybe you are not familiar with, but it's also known in business analytics, which is called Pareto chart. Pareto chart is another concept, another way to represent data. So let me start with the example to make it easier for you. Assume that you have a company that manufacture some type of bottles, and you notice that there is deficiency in the labels written on those bottles. So you classified those deficiency in different type or classifications. Some of them you name it as a crooked label, some of them were missing label, some of them they have some printing error on the label, loose label, maybe a wrinkled label and smudged label, and some other type of deficiency. And you went ahead and looked at all the deficiency bottles that came up maybe over the week, and you had a total of 211 bottles. And as you can see, the highest one was a crooked label. 78 of those bottles were having a crooked label. And as you can see, it goes in descending order. This is important for the Pareto chart because you're going to graph it from the highest to the lowest. So you have a 78, you want to take the percent, you only divide the frequency over the 211, the total, multiplied by 100, and you add the percent on it. And for each one of these categories, you're going to do the same. And of course, we'll sum up to 100% as total. Now, the cumulative percent is a very nice idea in which you start with the first one, you round it here, you say, okay, I have 37% of my labels were crooked. Now I will add with the second, so the second category here would be representing those two combined. So those two represent, as you can see here, 58.3%. Then I combine the three of them, it will give me this number, etc. And of course we'll end up with 100% as well. Now what we're going to do more is how we can chart this, the Pareto chart. So first of all, as I mentioned before, you put your items or the classification from the one that has the highest number to the lowest number, and always you leave the other, even if the other has bigger number percentage than the previous items, you always keep it to the end. So, and you read this chart as following. So first of all, you have the percentage element here, and you can look at the percentage from the other end. So the highest one as a percentage was about 37%, and that's will give you about 37% over here. The second one, 21%, will give you 21%, etc. So the left percentage represents the percent. And as you can see, the highest number we have less than 40%, so that's why you can see this number over here is 40%. Now the right side represents the cumulative percent, and it works as following. So you start with your number that represents the first number, the crooked label, which is in this case, if you plot a line over here, it should be in this place, which is about 37%. Then you do it cumulatively, that means you add on top of it the 21.63%, so you end up with 58%. So this dot here represents the 58%, 0.3%. So again, if you plot a line, it should end up in this location. The next one, 73%, again, it should be here, and always going to end up with a total 100%. So this type of representations is another way to see which one of those deficiency elements has the most percentage in your labeling problem. So this is one of those new charts that really helpful to represent the whole picture in a very small, easy way. So on the other hand, so we talked about the qualitative data. Now, how about the quantitative data? How you can summarize this data graphically? So as you can guess, you have all those numbers. It's very difficult to capture every number. So somehow we should think about it that we're going to group those numbers in a way so we can make the distribution or the graphical representation of our data easily understood. And usually we use the histograms. So this is what you do. You're trying to find or divide your data into classes, and then you say how many of those items represent in one class, how many on the second and third. To be more precise, let us take an example. So you have this example in your book about the e-billing case, and you have about 65 randomly selected invoices, and those represent the day that have been paid off. So this is like 65 different invoices randomly selected from more than 2,000 invoices available for the company. And accordingly, you can see that really we cannot get any meaningful information from this quantitative data. The only thing that I can see that the lowest number in this table is 10 and the highest is 29. That's all what I can see. So yeah, that's it. So those are just what I can see. So all those numbers are concentrating into those two boundaries between the 10 and 29. So how can I solve this problem? So we have to group those data into k number of classes. And I'm the one who's going to decide what k represents. And if you go back to your algebra, if I want to represent those classes, so all what I have to figure out is what is the value that if I have 2 to the value of k, it should give me 65. It's easy to remember if 2 to the 6 is 64, so I don't know if you remember the bits and bytes in computers. So 2 to the 10 is 1024, so let's go back one digit. 2 to the 9 is 512, so if you are talking about gigabytes and memory size, this is maybe will ring a bell. 2 to the 8 is 256, 2 to the 7 is 128, 2 to the 6 is 64. However, we have 65 invoices, so we have to consider k equals 7, 2 to the 7, which is 128. Okay, so now we know our classes. We know we have 7 different classes. How many numbers going to be allocated for each class? We know the upper boundary, which is 29, the highest number in those bills. The months, how many, which day in the month were paid, and we know the lowest was 10, the 10th day. So we divided over the number of classes we have, and we get about 2.7. We rounded to 3, so we would say for every 3 digits we're gonna have 1 class. So here are the classes, very easy. Class 1, we know we start by 10, add the 3 to them, so we start from 10 and less than 13 days they pay their bills. The second class start by 13 days and then they pay them less than 16. So you're adding 3 to all of them until you reach the last number. So at least the 29 will be included inside. So this is how you manipulate somehow. You convert, almost you're saying I'm converting my quantity data to qualitative data to be able to find the distribution, frequency distribution of my data and plot the histogram. Okay, so we're going to plot the histogram. So every one of these numbers, let me go back to the table. So let's say this is number 22. We'll look into my class and see 22 is in class 5. So in this way, if I am building the histogram, so will be in class 5. Okay, so it will be 1, 2, 3, 4, 5 will be allocated in this area. So it's the lower boundary of that specific class. So another way to represent the data as a frequency, as we did before, was qualitative data. However, also you can represent it as a percent, the same concept. So you divide the number of items over the total number of items, 65, and multiply it by 100 and you add the percent. So this is another way to represent the data. Now, when you talk about distribution and histograms, very known concept about if the data is skewed or not. So again, this is just a quick review about your knowledge in statistics, so we can build on top of it. So just a reminder so you don't forget it at all. When you say right skewed, that means the skewing is on the right side, as you can see here. And if you say left skewed, so the skew is on the left side. So the data are skewed in that specific area. Now you might have a symmetric, close to the bell shape, and that's what we like most of the time, but that doesn't happen that often. Now, cumulative distribution, we mentioned it before, also is called a running total, can be useful as well in the quantitative representation of data. So in our case, we had the first class that start from 10 days to 13, less than 13 days. We have the 3 items in it. So the cumulative is 3 from this point. We can create relative frequency. We divide it at the total number of invoices. We multiply it by 100 to get the cumulative percent frequency. The second element will be regularly, we have the second class has 14 items. If you look at the cumulative frequency, you are summing up the 14 with the 3, end up with 17. You divide 17 over the total number of invoices multiplied by 100. The third number is the same. You have 23 elements. You add whatever before those, you end up with 40, and etc. And you can chart them either as we did before, as you saw the distribution percent, or relative distribution, or cumulative distribution, or you can use something else, a chart called the OGIF. This chart, it uses a cumulative distribution, and you can use it with relative frequency or percent frequency. In this case is a cumulative percent, so you're starting by 0 if you go to the table. So this is 0, then you start actually at 10, the first class is 3, then 17, so you should see the first one here is 3, then you jump, let's see, you jump to 17, then you jump to 40. So you jump to 17 and then you jump to 40. Okay, another type of plot is the dot plot. This is maybe the simplest way to represent your data. Only works when you have very small data. So the same data we saw in our previous example, you can plot it, since we don't have a lot of data samples, only 65, so you can do it and plot how many times each one on that range between, in our case, between 10 to 29, and you plot every time you have repetitive in the same area. Here, another example in your book about the professor giving 2 types of exams. In the exam 1, he noticed a lot of distribution of the lower boundary, like students didn't do well. Then he started to apply an attendance policy, and as you can see, the data somehow was skewed left and getting better results, students getting more better in that exam from 75 and up. Still not perfect, but at least it really proved to help. Again, you don't use this one unless you have a very, very small data. And with the big data and with the concept of analytics, this will not work at all. But just as I said, this is just to review for what you know. Now, when you use contingency table, when you want to have some type of information from 2 dimensions, so you have the columns and the row, and you want to find the relationship between those 2 elements. This is one example also available for you from the book. You have 3 different types of fund, and they ask their customers about their satisfaction. So you have high, medium, low. From the first one, you can see most of the customers were satisfied, 15 and 12. The second one, also they were very highly satisfied. However, the third one, as you can see, it's the low and medium has the biggest number. So how we can represent this data in a better way? We can represent it by percentages. So you can, as we did before, you divide it over the all total number, and you get the percentage. So you can see the figures much quicker and much understandable. So you can see here the stock fund has a high satisfaction rate, where you can see immediately the tax deferred has a really low satisfaction rate. Now, we call this type of table, contingency table, cross-tabulated table. We can use it on quantitative or qualitative variable. And usually for quantitative data, we have to do the categories as we did when we classified the dates into those 7 classes in the previous example. Now, a very popular way to find the relationship between variables is to create a scatter plot. And now we are talking only about 2 variables. In the real life with big data, you will find hundreds of variables, and with cases that reach 100,000 of cases. So just the same concept, but on a bigger scale, we will be able to understand the data easily. So the scatter plot, this is a very simple. We have data about the sales volume and the advertising expenditure. So let's say the company did pay some for advertising, and they notice the more they pay for advertisement, the higher the sales volume. So there is a relationship. Those dots you can see, forget the blue line. Those are the data. So for example, if they paid, for example here, $5, they got 90 items sold maybe. This one here, if they paid $8, they had about 112 items sold. The last one, if they paid $14, they got about 130 items sold. So as you can see, there is a relationship, linear relationship, because we can put a line in line or maybe quadratic, also we consider it as a linear. However, this relationship is positive. It's increasing in x dimension and also in y dimension. If those dots were plotted on the opposite direction, like in this way, and we plotted a line in the opposite direction, we call it negative relationship. And sometimes we have no linear relationship, and we will see some type of those relationships in this course. Now, we should mention that a lot of advertisements on TV or even over the internet try to mislead the customers by just tweaking somehow those charts. So this is really important to understand. These 2 charts are exactly identical, nothing being changed in them, rather than the 0 was not mentioned in this chart here and started automatically from 58,000 and up. So somehow these differences, the small differences between each of those bars, were augmented to give you this impression that there is an increase in salary for the administrators in this hospital, for nurses and for the staffing maybe. So this is one of the stuff that you really have to pay attention to. Make sure that there is no increase in part of it, or the starting is not starting from 0. Another one, as you can see, misleading chart. Those 2 are identical, but someone changed the width of the bar number 4, give you more unequal bar width, make you feel like as if they were paid more, and there is a big increase in salaries on the 4th year. Now, as I mentioned in the first video, everything you see is optional in this book is not optional, just the opposite. This is a part that I want you to understand. This is a new field of business analytics and data analytics. Is added to this book because this is a new field, and in future we'll have more books just for business data analytics. However, it's really good because it's combined what you knew in the past and what you're going to learn in future. So first of all, what is descriptive analytics? Descriptive analytics can be using a lot of many different techniques, which allows you to summarize big data easily. So it merges both the classical type of statistics with the new type of analytics, in which have a very easy to understand visual summaries or up-to-minute information concerning operation status, for example, of a specific business. You will see a lot of different graphs introduced recently to the field of statistics that make it sound analytically more appealing and more easy to understand. So one of those, what is called the dashboard and the gates, in which you can see the information summarized in more than one way. So for example, this is the example given in your book in figure 2.35. They want to see the flight on time. So they have those charts for different type of flights, and their goal, there's an objective for their goal. See this thick vertical line. They want to have the arrival time to be all the time summarized over all the flights, maybe over the year, at least 80% of it arriving on time. The other one, departure, at least 90% arriving on time. And as you can see, in Midwest didn't really fulfill the objective of that year. They came short to that objective. However, Northeast was able to reach their objective. Their objective was 75. It wasn't 80. As their objective, they were able to reach it, and the same for the departure time. The Pacific, they were actually overperformed, and exactly the same with the departure time. However, the South, really, they did really bad with their objective. 70% where it was supposed to be 80, and here 70% where it was supposed to be 90. So another type of, another type is gates. So for example, you can compare those three different type of information about regional, short haul, and international, and you want to see if they utilize the fleet enough. 100%, that would be great. So as you can see in the regional, the utilization of the fleet was short, about 87.5%. The short haul was a little bit better, maybe 88. The international reached almost 90%, so they did the best. So we, in this book also, as I said, in supplement videos, you will find instruction on how to repeat those step by step and design them on your own with your Excel. Now, another type of analytical graphs, what is called the bullet graph. So if you remember the case of Disney waiting time, here, for example, we have 7 different types of activities you can do, and the way it's drawn, that you have the background is colored from green to red, and the actual time waiting for each of those activities is a black bar. So you can see immediately that if the first 5 type of activities are really, you don't have to wait more than about 25 minutes maximum, between 10 to 25. However, the last 2, you may have to wait more than 1 hour, for example, to this one, or 50 minutes. So this is a very nice, quick analysis that people can look at it immediately and tell a story from it. Again, also this video, there is a video associated with this graph that will help you to design it on your own in this unit 2. So we talked about this. Another type of chart we can draw with Excel is a tree map. So as you can see, if you wanna represent this data here about the ride and the number of rating and the mean of rating based on the ride in Disney, so you can see that just looking at the numbers really doesn't give you the big picture. However, if you just chart this with what is called the tree map, automatically you can see that the biggest number of the rating was the most loved one is Sorin, and then the lighter the green is less favorable, and the white is the least. Again, there is a video about how you can create a tree map, and it's really handy to start using those type of charts as your goal when you graduate from business college, to be able to read analytical charts. Another one from Excel, Sparklines. So assume you have this output about the monthly closing prices of 5 stocks. And you see those on TV most of the time. So let's say I have over a period of time from January to June all the information about their closing price. Looking at the data as numbers really doesn't give me a quick analysis. However, if I represent it as a sparkline, this is called sparkline. If I present it like a sparkline, you can tell the first dot here is a January value, and the June is the last one. There is a decline in stock 1, as well in stock 2 there is a little bit increase in decline. However, stock 3, if I bid on that stock or buy stocks from that one, I will have an increase in the value. The same for the stock 4. However, the 5 is declining. So this is another type of analytical charting that gives you the possibility to read the data easily. Now, the last part of this book is talking about data discovery, and this is where the business analytics and data analytics merge, which is what is called with data mining. And data mining is a big topic that allows you to forecast, allow you to predict, and allow you to do analysis on a big data. So, for example, if you have the airline example, the fleet utilization that we saw in the previous example, this one here, with those gigs, if we dig deeper in this data and we don't look at the overall or the average only, but we look into the whole year of the utilization of the fleet, and maybe divided by 4, so quarterly, so we understand what's going on in each one of those, and we plot it in this way, you can tell that how this airline really did, specifically for the international, for example, one of them, we did really bad in the first quarter and the last one. However, on the second and the third, did well. So now we can focus our work and find the reasons that we had a very low utilization in the first quarter and the fourth one. So this is what is called drill down into your data, analyze your data deeper, and try to find the element that can tell a better story than just looking at the average or the summary of your data. Now, quick reminder. As you saw, your course is divided into different units. Some of those units will be covered by 1 week. Some of them may take you more than 1 week. This is specific unit 2, is going to cover 2 weeks. Always try to pay attention to the instructions that I give you, what to do during those 2 weeks. Also, you have all the data set mentioned in your chapter, so all of them are available for you. So if you want to take a look and try any example in your chapter, just click on the link and the data will open in Excel for you. Okay, so let me go back. So the second unit you have until September 11. What you will have the supplement videos, so you can try to repeat what is shown in those supplement videos. You have homework 3, which is related to multiple type of questions. You will have about 50 questions, and this one only 10 points. However, the most important part is the homework 4, which has 50 points out of 1,000, which means 5 out of 100. It's a really important example assignment. you will have to repeat all the steps in Appendix 2.1. I will download the Appendix 2.1 and put it as a PDF file for you so you can print it out and work on your assignment at the same time. From pages to pages, you can see there's different data sets you can use. If there's anything missing, it's just to click on the big data and on the all data set, and you should be able to find it there. What I want from you to follow the steps in your book for all those data, then save all those Excel files into one folder with your last name dash first name, and then zip the folder and submit your assignment as a zip folder. That's all what you have to do for those 2 weeks. So you have the steps. It's not complicated. If some of those steps were difficult for you, go back to the supplement videos that I will be adding here. It can show you how you can do some of those steps from previous examples in Chapter 2. That's it for this unit, and we'll see you in the Unit 3.